Well, hello and welcome to our final week of online learning, and this is going to be our maths session. So for our maths, once again, we're going to do a couple of different sort of content-based structures. So we've got a bit for the first half of the week. Once you show me the awesomeness, then we'll move on to something for the second half of the week. So this video will explain both of those things. So you only have to watch the first half really for the first bit, and then the second half for the second half of the week. So what we're focusing on this week is we're going to be looking at the lattice method for our double digit or possible triple digit multiplication, depending on how you go. And we're also looking at factors and multiples for the second half of the week. Okay, so the good thing is the lattice method, all it does is just improves on from what we learned with our box multiplication. Okay, so it's a very similar setup. So we still have our square slash rectangle, so it still looks like that, but it's set up slightly differently, okay? Because what we do is we have diagonal lines running through it like that, okay? So some of you may remember that from last year. Now, for example, if my number sentence is 37 times 69, same as. Okay, so that's my number sentence, and the way that we work it out on this is a little bit different to the box method. Now, some people find this way easier, some people don't. But the thing is, I'll give you another strategy to see which way you like better. So what needs to happen is, so instead of the multiplication sign being on this side, it needs to go over to this side. Okay, so we go like this. And this one here, we don't really look at its place value. So you know, in the box method where we had to understand its place value. Whereas, for example, the 3 here, that was worth 30. This here, it doesn't matter. We're just looking at it as numbers, and all we need to know is our basic times table skills. Okay, so let's start off here. So we put our 3 and our 7. So each digit has its own box. So we've got 37, then we've got 69 left. Got 6 and 9. Okay, so there's no place value needed whatsoever, but it is the same process as the box multiplication. So what the digits need to do, they need to go walking. Okay, so I've got the digit number 3 up here. When he goes walking, who does he meet in this square? He meets the number 6, because the 6 goes walking here. So what you have to do is use your times table knowledge and go, okay, what is 3 groups of 6? So 3 groups of 6 is 18. And that's why we have these 2 boxes here. Because one's a tens column, one's a units column. The top one's the tens column. Okay? So 3 groups of 6 is 18. Then 7 goes for a walk. 7 groups of 6, because that's where they meet here, is 42. And 7 groups of 9 in this box, we have 63. And 3 groups of 9 meet in this box, because 3 goes for a walk, he stops here, 9 goes for a walk and he stops there, and that is 27. Now this is the area where a lot of people have a bit of an issue. Okay, now our place value technically runs in diagonals instead of up and down in this one. So we have to have a look at every digit in the diagonal columns, because that is the place value. So if we have a look at this diagonal one, we see that there's only 3 in that column. So that means 3 is just on its own. We look at this diagonal column, and we see there's a 2, a 6, and a 7, all going in that diagonal column. So that means we have to add those numbers up, like we normally would. So 2 plus 6 is 8, plus 7 is 15. So it's the same process as when we did our addition algorithm. So so that is 15. So we need to put down the 5 in this place value column, And then what we do is we carry the 1 over to the next diagonal column. Okay? So our next diagonal column, so we've got our 1 to start with, so we go 1 plus 4 is the same as 5. So 5 plus 8 is 13, and 13 plus 2 is 15. So once again, we put down the 5 and we carry the 1. Then we have 1 plus 1 is 2. Okay, and then what we need to do is we need to go, okay, we've got this digit, this digit, this digit, and this digit. So 37 times 69 is, so we've got the 2, then we've got the 5, then we've got the 5, then we've got the 3. Okay, so 37 groups of 69 is the same as 2,553. Okay, I'll quickly go through another one just to show what could possibly happen on a few others. So the main thing that you have to remember is the place value columns go diagonal in this one, not vertical. All right, so I'll do another one. We'll do 36 times 23. Or no, we had 22. All right. Same thing. You'll already have these boxes drawn up for you, so you don't have to worry about any of that. I'll put my diagonal columns in. Okay. I'll put my multiplication sign over this side. As I said, you will already have that set up. And then I've got to put my numbers, my digits in. So I've got my 36 times 22. Okay. So once again, they start walking. 3 and the 2 meet in here. Now 3 times 2 is 6. So how do I represent 6? Like, where do I put just a single digit? Remember, the top part of the box is the tens column. Okay. So if 3 times 2 equals 6, is there a digit in the tens column? No. So what you need to do is you need to just put a 0 here and then put the 6 down there. Okay. And then we just go for a walk again. 6 meets 2 in this box. So we've got 12. 6 meets 2 in this box again. So we've got 12 again. And 3 meets 2 in this box because they go for a walk. So it's the same as up here. Okay. The top half of that box is a tens column. So there are no tens, and we've got 6 ones or units. Now once again, we look at our place value columns which run diagonal. So 2 is on its own in the units. In the tens column we have 2 plus 1 plus 6. So that's 2 plus 1 is 3 plus 6 is 9. So we don't need to carry this time. Then we look at our hundreds column. We've got 1 plus 6 is 7 plus 0. So 7 plus 0 is 7. And in our thousands column, we actually don't have anything in our thousands column. So we look at our digits. 792. So that is our answer. Okay. So that was just a way to show you what happens if you have to put down zeros and stuff like that. So that is the first half of our week. We're working on that box multiplication. So, the latest method, which is furthering on from the box multiplication. So some people might like using it this way, and when we come back to school, we're going to learn the traditional algorithm. And then you've got 3 options to choose from when you're doing your double digit or triple digit algorithm. So that's for the first few days. So you can stop this video now. You don't have to watch any further. Now, because for the second half, we're going to be doing factors and multiples. Okay. So when you're up to factors and multiples, then you can watch the video again. Okay. So for factors and multiples, this is all about having times table knowledge. Okay. Multiples are basically a really technical way of saying skip counting. Okay. So for example, if we all know how to skip count really well. So if I'm going to skip count, I'm going to go 6, 12, 18, 24. Okay. So you would have guessed that I am skip counting by 6. Okay. Now what happens with multiples is we actually ask if a number is a multiple of another number. So for example, I could say, is 24 a multiple of 6? And we go, well, we can skip count by 6 to get to 24. So yes, that means 24 is a multiple of 6. Now sometimes obviously it'll get harder. We'll go, okay, is 660 a multiple of 6? Now this is where sometimes you use your, this one here, we could use our powers of 10 knowledge. Okay, so we go, okay, somebody asked me if 660 is a multiple of 6. Well, if I look at the first two numbers here, first two digits, that's 66. Now, is 66 in the 6 times tables that I know of? Yes, yes it is. So that means if 66 is in the 6 times table, that means 660 must be as well. Okay, so then we will go, yes, 6 is a multiple of 660. We'll try another one there. I'm still using the number 6. All right, we'll go 124. Okay, we go, is 124 a multiple of 6? Now this is where we have to start using our strategies. Okay, now we go, some of us may look at it and go, oh, okay, let's have a look. Oh, 24, I can see 24 is a multiple of 6. So that must mean that, yes, 124 is a multiple of 6. But then we've got to go back and have a look a bit more, okay? Because then we've got to identify things. So we've got 124. Once again, we can use our powers of 10 knowledge. And we have a look at it and go, okay, let's just work on the 120 part. So that's the 12 there. Is 6 a multiple of 12? Sorry, is 12 a multiple of 6? Well, yes, because it goes 6, then 12. So we know 120 is a multiple of 6. So we go 120, big tick in our head. That is a multiple. Then what we need to do is, okay, from 120 to get to 124, we have 4 left. Now, is 4 a multiple of 6? No. So that means 124 is not a multiple of 6. Okay, so the multiples are a really good one for actually you utilising your strategies of powers of 10 and your times table knowledge. Okay, we'll try another quick one for a different number. So for example, I've got the number 3. We'll say 57. Is 57 a multiple of 3? Okay, let's start using some of our times table knowledge. All right, we know that 10 times 3 is 30. So we go, all right, 10 times 3 equals 30. So then if 10 times 3 equals 30, how about we just double that? Because that should be pretty close to 57. So if we double 30, we get to 60. So we've got 60 there. So that must mean 20 groups of 3 equals 60. So then we go back and go, okay, now we can actually figure out whether it could be it or not. So if we have a look, what do I need to take away from 60 to get to 57? So we go 60, we go 59, 58, 57. So I need to take away 3. So if I need to take away 3, that means that 57 actually is a multiple of 3. Now, when you very first saw it, you probably go, oh, no way. But when you break it down, so you could do it this way, or you could go 10 groups of 3 equals 30. And then some people would go, okay, 9 groups of 3 equals 27. And then what we do is we add those up. Okay, so finding out multiples is actually all about you knowing your times table knowledge and using some strategies with either powers of 10 or your addition. So that's how we figure out the multiples. Okay, so that's part 1 of it. Now with multiples, factors go with that as well. And these are the type of things that we look at for factors. So factors are slightly different. So factors, you need to figure out what makes up the number. What can be multiplied to get to this number? So we're going to start off with, say, 12. Okay, so that is my number. And I'm going to say, please let me know what the factors of this number are. Now, this is very important to know for times table knowledge, as well as when we start doing some fractions in term 3. Okay, so what could I possibly multiply with it to each other that gets to 12? Now, the very simplest and easiest one is the actual number and 1. Okay, so we've got 12 and we've got 1. Okay, because 12 groups of 1 equals 12. Are there any other two numbers that I can multiply that get the 12? All right, let's have a think about it. All right, so I know 3 groups of 4 equals 12. I know 2 groups of 6 equal 12. Okay, now are there any other ones? No, that's it. So for example, if I say, what are the factors of 12? I would say 6, 2, 12, 1, 3, and 4. Now, one handy hint. This is an even number. If it is an even number, what must be a factor? Okay, I'll tell you. 2 must be. So if you're ever asked for a factor of an even number, 2 has to be one of them. Because if it's an even number, that means it can be divided equally. Okay, so that's the factors. We'll work on another example. Let's work on 20 this time. 20. Okay, if I say, what are the factors of 20? Let's have a look. All right, so once again, the easiest one is the actual number and 1. Now, knowing what I know now, okay, it's an even number, so that means 2 has to be a factor. So I've got 2. Now, what's 2's partner? 10. Okay. Okay, what else could I do? All right, well, 5 and 4. And they are the factors. Now, the way that we'll be doing these is, for example, is I'll give you a number like this. And what you do is you need to write the factors down. Now, if you do it in order, that's good, because then that's a way that you can understand it. Because what happens is, if you do it in order, you go 1, 2, 4, 5, and 10, and 20. You can actually see what the pairs are. Okay, so my pairs are 1 and 20, 2 and 10, and 4 and 5. Now, there are some numbers that only have itself. So for example, a number like 36, it has 6 as its factor, but it doesn't actually have a partner, because 6 times 6 is 36. So there will be some numbers there that won't have a partner. But most will have a partner there. So you can either set it up like this, or you can just go 20, and you can put the partners together. So you can have your 1 and your 20 together. You can have your 2 and your 10 together, and your 4 and your 5 together. Okay, so it's totally up to you how you sort of do it on the sheets, but you'll get a better idea of how I show you how we're going to do it on DB anyway. But that is the factors and the multiples. Okay, so remember the most important things for the factors and multiples. If they are multiples, it means it's basically skip counting. You need to know, okay, can I skip count from this number, from this digit, all the way up to the number? Okay, but you must use your strategies of basic place value. You must use your addition. You must use your powers of 10. With factors, it's all about what can be times together or multiplied together to get to a certain number. There, 90% of the time, there will be a partner for it. Okay, like here, 1 has a partner, 2 has a partner, and 4 has a partner. There will be some numbers that do not have partners. But that is our learning for this week. So the first half of the week was the lattice method, and the second half of the week was factors and multiples. Okay, so hopefully you can show me some awesomeness in that this week.